So we decided my Teflon rod has 18 million coulombs of charge, but it has both positive and negative charge, and they cover each other up, and it comes out neutral. So now we have to figure out, how do you get a macroscopic object to charge up? And the answer is you charge by rubbing. It doesn't sound very technical, but that's actually how electrostatics got started, is charging things up by rubbing. So what I'm going to do is rub this Teflon rod with this cat pelt. So, unfortunately, one animal did die for the sake of physics 102X. It was an ugly cat, though, so nobody really cared. And as I rub it, we're going to have 3 lines of evidence that something is happening. Okay? The first is sound. As I rub this, you can actually hear sort of a crackling sound. Let me hold it close to my mic. It kind of crackles. Right? So you got a sound. For the second, I'm going to have Alex come. Alex has been helping me with the class, working on some of those 3D visualizations. Hello. And I'm going to have him hold out his bare arm, and I'm going to bring the charge rod near his arm. And what does that feel like?
Feels really tingly.
Tingly. Excellent. Exactly what it's supposed to feel like. Tingly, thanks. That feeling is called formication. That's F-O-R-M-I-C-A-T-I-O-N. That's a medical term for a tingling sensation. So you always feel that near a charged object. So there we go. We got sound. We have formication. A third effect that you can see with a charged object is I'll take these pith balls. These are little really light balls that have been colored to look nice, and they tend to get charged up. And if I bring the Teflon rod charged near the pith balls, you can see as I move it across, they start to move and they fly around under the influence of the charged rod. So there you have something begin to move. It felt a force. It has a mass. It went from 0 velocity to some higher velocity, so we applied a force. So that's 3 things going on. So clearly something is happening with this rod when I rub it with a fur. So let's look and see if we can figure out what's going on. Well, at first, the Teflon was neutral. So if we were to zoom in on its surface really hard, we would see atoms, little nuclei here, and they would have electrons going around them. So we'd have positive and negative charge. It's right on top of itself. So this is how it's neutral. And if we were to take the fur over here, same story. If we were to zoom in on it, the surface of the fur, really hard, there'd be little fur atoms. I mean, they're not really fur atoms, but you know what I mean. And they would have positive nuclei, negative electrons going around. Everything is neutral. But let's think, what would happen? What happens when we rub something? You might think these are chemical bonds. I mean, nothing's going to happen when you just rub. What you got to remember is when you rub, you're taking the energy from your macroscopic muscles and you're putting it only in these surface atoms. That's a lot of energy you're dumping into that surface. It's definitely enough to strip off atoms. Okay? Or, I'm sorry, to strip off electrons. So electrons get loose, and what happens is you end up with more electrons tend to go to the Teflon, and more electrons tend to leave the fur. So what I can do is redraw this row. The nuclei are still there, but now it's sort of deficient in electrons, like that. So if we transfer some charge, now the balance is not neutral. Now the Teflon comes out negative, and the fur comes out positive. That's what's going on at a microscopic scale. This is called the triboelectric effect. And unfortunately, it's very complicated. You can't just calculate how much charge is going to transfer in a triboelectric experiment. It depends on the exact surface chemistry, the previous surface treatment, and the previous surface chemistry. It depends on the humidity in the air, what kind of gas is in the air, how hard you rub, how fast you rub, what kind of fur it is. It depends on a lot of things. It's not really an exact science. However, people have been studying it for centuries, and what you do to study it is you make a table. So this is called a triboelectric series. It's a list of materials, and at the top are materials that tend to come out positive, and at the bottom are materials that tend to come out negative. So if you rub 2 materials on a triboelectric series, wherever they are on the table tells you what happens. You know, if we rubbed cat fur and Teflon, so Teflon's at the bottom, it came out negative, cat fur is at the top, it came out positive. The lists are always kind of weird. There's always different kinds of fur, and rabbit's always above cat, and nobody knows what's going on. But some aspects of it you can actually understand in terms of chemistry. So think back to chemistry. One of the first things you learn in chemistry is electronegativity. That's basically how much does each atom want to hold on to electrons and grab electrons. It's a function of their atomic and electronic structure. And you may remember from that table, or from that periodic table, labeled for electronegativity, that fluorine was one of the most electronegative elements. It turns out Teflon has a lot of fluorine on it. Teflon is basically plastic where all the hydrogens have been replaced with fluorine atoms. So chemically, it actually makes sense that Teflon's way at the bottom. It loves to grab atoms, or it loves to grab electrons. Always ends up negative. That's why I use it in the demonstration. So charging things by rubbing doesn't sound too technical, but it's definitely the way we get started in electrostatics.